Okay, so we've spoken a little bit about ad hoc configuration of nodes to be able to connect directly with one another without using an access point or the like. And this is really for distributed systems rather than distribution systems that we have here on this slide. So it can do it. What's a little bit frustrating is that the support for this has kind of been a little neglected in Wi-Fi over recent years, and in things like Android and other mobile operating systems, the support for it that was there was removed because of a variety of factors. One is just the chilling effect of them being afraid of upsetting the mobile phone operators by having a means of direct phone-to-phone communication rather than it having to go via the cellular network. So one area where this was perhaps a little bit more frequently used was actually to have the connections between access points form in this ad hoc manner, and then have the clients still connect to an to an access point in order to minimize their energy consumption. So again, you can have the multiple access points sharing ad hoc connections amongst them, and then as the nodes move around the clients A through H between the range of coverage of the different access points, AP1, AP2, and AP3, that it's possible to give the impression for those clients that they are on just one big network through the clever operation of the network. And again, this gives something which feels then very like the cellular network, in that you can move freely from one cell of coverage to another cell, and your call doesn't drop out, your internet doesn't drop out. But at any point in time, each node is communicating only with one access point, and if it wants to communicate with a node which is on a different access point, then the distribution system and the access points are actually responsible for forwarding those frames on for them to get to their destinations. So there's multiple hops required to deliver the traffic. So if a node can see multiple access points, or more the point of it, if it wants to connect to any, it needs some way of connecting to them and to decide when to switch to another one. So nodes will typically scan for access points, and then the node will send a probe to the access point it would like to join, and the access point, or all access points within reach, will reply with a probe response, and the node picks whichever one it wants to connect to, maybe based on apparent signal strength or some other kind of measure, and will send an association request. And then finally, the access point will respond with an association response frame, at which point the node has joined the Wi-Fi network. So it has to do this whenever it wants to join the network, and it also has to do it if it wants to switch access points. So for example, if the signal on the current access point is getting low, but beacons from another access point look quite strong, it may decide, I should probably try and switch to that other one. And so then it will attempt to do so. And it should also actually inform, when you're doing the handover from one access point to another, it should also communicate with the access point that it's leaving, as well as with the one that it's joining, to ensure that the network knows where to route the Ethernet frames to each client. So for example, if C is moving from the range of access point 1 to the range of access point 2, so we'll be sending its probe frames, and eventually we'll get a probe response from AP2 as it's thinking about as it's physically moving across here. And at some point, it figures that AP2 has a higher signal strength than AP1, so it will associate with access point 2, and then disassociate from access point 1. And so where the client is actively doing this, this is called active scanning, because the node is actively scanning for the access points. As I mentioned just before as well, that the access points are periodically sending a beacon frame that advertises the existence of the access point, as well as its capabilities. So which particular flavors of 802.11 it supports, the transmission rates that it can handle as a result, And so the nodes can just listen for these beacons. And so this is passive scanning. So a node can switch to an access point in response to one of these beacon frames simply by sending an association request to that access point. So we can skip those first two. If we go back, we can skip the probe frame and the probe response frames because it's actually listening to the beacons coming from the access point directly. So that can be faster to associate. Okay, we'll talk about the 802.11 frame content.